Hi there, this is Shivam. In this video, we'll discuss how to integrate Vert.x with Spring Boot. So let's get started. Before we move forward, let's have a brief introduction of the Vert.x. Vert.x is a reactive toolkit to build JVM applications. Because it is a toolkit and not a framework, it is naturally very composable and embeddable. Also, Vert.x is an unopinionated library, which means that it doesn't have any strong opinions about the project structure. These characteristics of Vert.x makes it a good candidate to integrate with other frameworks such as Spring Boot. Next up, why integrate Vert.x with Spring Boot? At the time of recording this video, Vert.x doesn't have any built-in support for the dependency injection. Integrating with Spring Boot makes it possible to utilize the dependency injection in the Vert.x application. Vert.x provides config stores to manage the application configuration, but it requires some boilerplate code. The developer needs to define the config stores for the system configs, environment variables, and the config files. However, the configuration management in Spring Boot is very familiar to most of the Java developers. So the same can be utilized with the Vert.x application. Integrating with Vert.x with Spring Boot gives us best of both worlds. Spring Boot provides unique features to maintain large projects with ease, while Vert.x has very solid performance in reactive web applications. The idea behind the implementation is the Spring Boot will initialize the Spring context, creating all the beans, injecting all the beans and values, but Spring Boot will not initialize its embedded web server. After the Spring Boot has initialized the application, it will trigger Vert.x initialization. During initialization, Vert.x will deploy its vertical, which will internally create the HTTP server and bind it to the specific port. Effectively, Spring is only responsible for the application initialization process, and Vert.x will handle the actual web traffic. It is possible to integrate Vert.x with Spring Boot at a much deeper level than this, but that introduces an overhead for each request to the web server. However, the showcased integration is a sweet spot where we get few benefits from Spring Framework without sacrificing the performance. We will compare the performance metrics and other relevant metrics later in this video. Let's jump to the code now. Here I have opened start.spring.io where we will generate an empty Spring Boot project. We can go the other route as well, where we generate a Vert.x project and then put the Spring Boot dependencies in it. But I like to start with the empty Spring Boot project. So here, I'll just change the project type to Maven and I'll keep everything as default and I'll just hit generate. We don't need to add any dependencies from Spring side as we need Spring just for our application initialization. I have extracted the zip file and opened the project in IntelliJ. Let's first head to the pom.xml file and add the Vert.x dependencies. So here I am in the pom.xml file and first we'll add the dependency management for the Vert.x stack deep chain. So I'll add dependency management. Inside that dependencies, inside that one dependency, group ID will be io.vertex and artifact ID will be vertex-stack deep chain. We can bump the version to 4.4.4, which is latest. Additionally, I will put the type as pom and scope as import. Vert.x stack deep chain makes it easier to add multiple Vert.x dependencies, and we don't have to specify any version specifically for each dependency. Now we can go ahead and add the Vert.x dependencies. I will add 3 dependencies for now: Vert.x Core, Vert.x Web, and Vert.x JUnit 5. As the name suggests, Vert.x Core provides the core functionality for the Vert.x application. Vert.x Web provides the special constructs, which makes it easier to create web applications such as router. Vert.x JUnit 5 is for writing the unit test cases. So let's add these dependencies. So we'll put here dependency, group ID as io.vertex, and artifact ID will be vertex-core. We don't need to specify the version. Repeating it for Vert.x Web, dependency, group ID will be io.vertex, and artifact ID will be Vert.x-web. Again, no version required. Then dependency for Vert.x JUnit 5, group ID io.vertex. Dependency will be Vert.x-JUnit 5. No need to specify version, but I will add the test scope to restrict the scope of this dependency to test only. Now that we have our dependencies in place, let's do a Maven sync. Post the sync, let's jump to the file with the main method. In this case, it is the demo application. There is a banner that project JDK is misconfigured, so I'll set up SDK as Java 17. I am prompted to do a Maven sync again, so let's do that. Because we did not add the Spring Web or Spring Web reactive dependencies, so the Spring will not initialize any HTTP server, but I still like to explicitly define the application type as none. So let's replace this line with new Spring application builder, passing in the class name, which is demo application.class dot web with web application type dot none, and then dot run, passing in the args. We have now configured Spring to never initialize the web server even if it is in the class path. Now let's declare the beans that we need for the Vert.x application. Let's create a new file, configurations. New class, configurations. I'll mark the class with @configuration annotation. We basically need two beans for now. One is Vert.x and one is router. So let's declare those. Public Vert.x, get Vert.x, return Vert.x.Vert.x. I'll declare the method as bean. And then second one will be public router, get router. I'll import the router dependency. The router depends on the Vert.x, so I'll inject the Vert.x here. Vert.x, okay. Inside, I will do return router.router, passing in the Vert.x. I'll declare this method as bean as well. Now let's declare the property for the server port. Let's open the application.properties file in the resources. I'll declare one property, Vert.x.spring.port equal to 8000. After this, we need to define a Vert.x vertical which will create and register HTTP server. So let's create the main vertical file. I will extend this class from abstract vertical. I will mark this class as component. We need to inject the router and the server port which we have declared earlier. We don't need to inject the Vert.x as we'll get the Vert.x context reference from the abstract vertical class itself. So let's declare router and server port. For both of these, I will do add constructor parameters. Let's put @value for the server port to identify the property name. Vert.x.spring.port. And it's not required, but I usually prefer to mark my constructor as auto-wired. Let's also declare the logger. private logger equal to logger dot get logger, passing in the class name. So I'll do main vertical dot class dot get name. Now let's override the start method where we initialize the HTTP server. So I'm overriding the start method. I will override the start method which takes the start promise itself. Here I'll do Vert.x dot create HTTP server dot request handler as our router, and then dot listen, passing in our port which is server port, and we get a callback, HTTP callback. First we will check if our callback has succeeded. So if HTTP dot succeeded, and then we can have else block as well. Here I want to log with level info HTTP server started on port, and we can pass the port value here. And I can complete the promise, which is start promise dot complete. In else case, I want the start promise to fail. So I'll do start promise dot fail, passing in the cause as HTTP dot cause. We can remove the redundant exception thrown in the method body. So now that we have our main vertical created, we need to deploy this post the Spring initialization. Let's use command line runner to achieve this. Let's create a file Vert.x runner. We'll mark this file as component, and it will implement the command line runner. We'll override the run method. We need to deploy the main vertical in the run method. So let's inject the Vert.x and the main vertical. Again, I'll add constructor parameters for both of them, and I'll mark the constructor as auto-wired. Let's declare the logger as well. We'll pass in this class name Vert.x runner dot class dot get name. In the run method, we will call Vert.x dot deploy vertical, and we'll pass in the main vertical. It returns a handler. We can use that to check the status. So we can have dot on success. In this, by default, we get the deployment ID. We don't need that. I'm still marking it. And we can just simply log logger.log level.info successfully deployed the Vert.x vertical. Then same way we can have the on failure. In that we get the exception which is throwable. So first we'll log the exception and then exit the application. So logger.log level.sphere, which is equivalent to error. We can say here failed to deploy the Vert.x vertical. And this can be the placeholder for the exception. After logging, we'll do system.exit with a non-zero code, so -1. We also need to close the Vert.x context when the application is shutting down. So let's register a pre-destroy hook. I'll create a method. Let's call it destroy. We can annotate the method with @pre-destroy, this one. One side note here, we will not use logger in this method as logger might shut down before this method is called and we won't receive any logs. There is a way to set up the logger in the proper manner to overcome this issue. I will show that in another video. So here we need to call vertex.close. As you can see, the vertex.close returns a future. So vertex.close is happening in async manner. Let's use countdown latch to make it sync. New countdown latch of 1. I'll cast it into a variable countdown latch. In vertex.onClose, I will do onComplete. I'll get a handler with a callback. So let's name it handler for now. In this, I will check if handler.succeeded. Then I can just say my Vert.x application has closed. So successfully shut down Vert.x. In either case, we have to do countdown latch dot countdown. Post this, we will do countdown latch dot await. We want to specify a timeout so that it doesn't wait indefinitely. So the timeout can be 30 and time unit can be seconds. We will see that await throws a checked exception. So we need to put this in try catch. I don't want to do anything in the catch, so I can just remove that and mark E as ignored. And then I can put a finally block, and in the finally block, I'll simply put exiting the application. We can also put a print statement at the start of this method saying shutting down Vert.x. With all these integrations in place, we can now declare the endpoints. Let's create a hello controller class. We will mark this class as controller, which is just an alias for the component. To define the routes, let's inject the router. Private final router. We will get this as a constructor param. So add constructor params. Now we'll define the endpoints. So I'll create a method define endpoints. In this method, I'll register our endpoint. So router dot get, I'm calling the path as hello dot handler. We will get routing context here. So routing context. So inside, first we'll get a reference to the response. So routing context dot response. In response, we will do response dot set status code. I'm putting 200, which is http response status dot ok dot code. And I will just send plain text dot end hello from Vert.x inside the Spring. So this should complete our integration. So let's test it. We'll go to demo application and run the application. We can see the logs that HTTP server started on port 8000 and we have successfully deployed the Vert.x vertical. Now let's test it from the browser. So here I'll type HTTP localhost 8000 slash hello. And we can see we are getting response hello from Vert.x inside the Spring. So this effectively concludes our implementation. Now that we have integrated Vert.x with Spring Boot, let's check out how are different metrics impacted as compared to vanilla Vert.x application. Starting with startup time, we can observe that the startup time has increased a bit with this integration. It is largely due to Spring creating and injecting beans at the startup. As long as the startup time is within the acceptable limits, we don't need to worry about this metrics. Then we have idle RAM usage. We can observe that with Spring integration, the idle RAM usage has increased by almost 141 MBs. This is because all the Spring references are being retained in the memory. But this difference in RAM will stay constant and will not increase at runtime as a result of this integration. Next up, we have fat jar size. We can see that the Spring integration has increased the fat jar size by almost 10 MBs. This is because the Spring starter dependency is also being packed in the final jar. Now, let's check out if there was any impact on the performance with this integration. As we can observe that the performance wasn't impacted at all. Both the RPS and the latency are almost the same and within margin of error. And we expected this because the Vert.x is still in charge of handling the requests directly. Moving on to the RPS for the dynamic response, we can observe that the story is still the same. There is no sacrifice in terms of performance with this integration. Thanks for staying tuned. If this video was helpful, press the like button and subscribe to the channel for future videos.